Yeah, g'day, Mark here, and welcome back to my channel. Now I need to make more tool holders for my lathe, and therefore I need to make some 60-degree dovetails. So I made a 60-degree dovetail cutter using DCMT Inserts, and it was a crappy design and failed about halfway through the job. So based on my lessons learnt from that crappy dovetail cutter, let's design a better one, make it, and see if it works. Oh, and I got some exciting news. Stefan Gotteswinter and I enjoyed our last live stream so much that we're deciding to do another one. So it'll be a few hours after this video goes live on the evening of the 24th. Love to see you there. I would love to get the automatic tool changer working on my lathe. It's this lovely little carousel device, all very nicely made, but it doesn't make much sense to put the effort into getting it working if I don't have enough tool cassettes to really use it. However, what I do have is a box full of half-finished tool holders, some of which I managed to get the dovetails cut on, but my homemade dovetail cutter turned out to be a bad design. Before we can make a new tool, we have to work out why this tool failed about halfway through the job. Now my tool holders need a 60-degree dovetail, so I figured I can just cut them with a 60-degree triangular insert. That's nice and easy. The problem with this idea though is that even if you're cutting in from one side, you're going to have full contact on both surfaces, causing chattering and rubbing on at least one of the surfaces. But it's actually worse than that, because the way this has to be mounted means it's only supported along the back side. And therefore, any forces that come from rubbing at the bottom are going to try and push the insert this way, and any cutting forces are going to push it that way. And if they're not perfectly even, you're going to get vibration and chatter. And that vibration shows up as poor surface finish on those surfaces which I already machined with the old dovetail cutter. And all of that load is going to go straight onto the little screw, which is just this tiny little M2.5. And it doesn't take much to cause fatigue and have that screw shear off. So the first thing I'm going to need is an insert that has an included angle of less than 60 degrees. Anything less than that's going to give me clearance under here and it's not going to rub. So the obvious choice is DCMT, which have a 55-degree included angle. Now my triangular inserts were only 2mm thick with their little 2.5mm hole. By going for DCMT T3 inserts, they're twice as thick, and they have a much bigger screw, 4mm instead of 2.5, and will therefore increase the clamping force and help reduce any vibration there. And the final big advantage of switching to these inserts is that it allows you to have a tool pocket which supports the tool on two sides, reducing the chances of movement, reducing the vibration, and therefore reducing the chances of chatter and tool damage. But it does make for a slightly more complicated design because I now need to machine out a tool pocket that looks like this. I designed this tool in Onshape, which is my preferred CAD, and they do have a beta version of Cam Studio, it's called, for creating toolpaths, but I kind of got lost in all the menus. They're still working on the GUI for that. Even with the help of the developers, they provided me with some toolpaths, but I couldn't really tweak them to make them work. So I ended up switching back to my old version of FeatureCam to generate these toolpaths. Now with those new inserts being both bigger and longer, I'm going to need more space for the tool pockets, and therefore I'm going to need to make a bigger tool. Now the maximum size of tool that I'm going to be able to work with is going to be 45mm. I'll make it out of a bit bigger stock than the last one. Well, I went through all my scrap, and I do have this, which was bycatch for maybe the Schaublin. I mean, it's beautifully machined. It's a big expanding mandrel, but honestly, I've got no use for it. And in fact, I've got two of them, which I have no use for. So I figured I may as well start cutting these up and making something useful rather than leaving beautiful bits of scrap metal around that I'll never use for anything else. Yeah, it's a shame. Someone put a lot of work into these, but as I say, I'll never use them. I have no idea what alloy it is, but it's not hardened. It's more like 50mm, and I think 60 up here, or 55 or something. This one's roughly the same. So the new dovetail cutter should end up about 80mm long. So I'll chop it through here. To cut such thick steel, I'm going to need a more coarse blade. Someone in a previous video recommended I use uneven tooth blades, and that's what this is. To stop it rolling, I've put a vise on one end, and I think I'll actually use the power feed on this. It's going to take a fair bit of pressure, and after a while your hands get sore pulling it through. The power feed is this big steel bob weight here, and there's a foot pedal on the other side which you lift it with. With this wheel you can adjust where that bob weight is located, and therefore adjust how much tension it puts on the cable. Okay, I just realized that my chain is hitting here, so it's not pulling anymore on this side. I think this is an endless loop, so I just need to adjust it around so that I've got a sort of an equal length of pull on both cable sides. But it's working really well. It's much easier than having to drag it through with your hands. Well, that worked great. I'm glad I used it. Have to remember to use it more often. Right, while I was at it, I chopped the petals off as well. I think what I'll do is just chop a bit off the end of one of these and try heat treating it, because I don't know whether this is a tool steel or not. Kind of suspect it probably would be, seeing as someone went to all the effort to make it, but they didn't harden it, so maybe it's not a tool steel. It cleaned up nicely. If this is 0 millimeters, I can safely go back at least 55 millimeters. We're starting at about 50 millimeters. Let's just start off by going into 48. We need to go back to 55 negative. We want no taper, we want no radius. So that's all looking good. Let's start. Might have seen in there that halfway through I increased the RPM, and it's definitely given it a nicer surface finish. This is 48 millimeters. I need to go into 25 millimeters. Let's try 3 millimeter depth of cut. Wow, that insert sure likes that 3 millimeter depth of cut, and that steel, the finish is fantastic, and the chips broke beautifully as well. Great, that brake worked well. Okay, that return pass screwed everything up. Okay, let's try that again from the other direction. Okay, that's looking better. I'll probably end up with one mark on the end of this. Let's go another 2 millimeters. mail time. Now this has come in from Malta, from my mate Luke. He visited me on his way to Chicago. I'm pretty sure that he and my wife had some little dodgy deal going on about my birthday, which was a while ago. Somewhere in here is the birthday present which my wife purchased from Luke. Wow, nice packing, Luke, good one. Whoop, they took a bit of a hit. So this is a nice instrument case. What is it, a trumpet or something? So what we have here is a nice gyre wheel, made in France. This is basically a pneumatic grinding head. So this part here is the grinding head. I'm guessing it takes probably some sort of collets. Pneumatic pressure coming in here makes this spin fast, and you can use it for doing internal grinding, but you can also use it for engraving, supposedly. This big beast is some sort of a head which allows you to set an offset so that it can like spiral down and grind a certain size. At least that's my understanding of it. Then there's a normal head that just mounts it directly. So basically you have the option of either, with a CNC machine, you can either let the machine do the spiral, or you can use this, let the machine drive down straight, and have this provide the offset. For your little drag kit, you've got, oh no, wait a minute. So there's collets here, probably for the most standard sizes, I guess. That looks like some sort of an extension or something. Not quite sure what that's for. Okay, that looks like a center finder. This looks like some sort of precision something. Maybe it's also for holding an indicator or something. Let's hope it's in the manual. So this is used with a diamond to dress the little cutting wheel. Aha! Now this is the scale ring which Luke made to complete this new cross slide for my Clarkson tool and cutter grinder. Man, the quality of your engraving is fantastic, Luke. That looks beautiful. Thanks a lot. I still need to turn the nut to fit onto the cross slide, but that'll be great to have a new cross slide assembly which is not worn out, turns in the correct direction, and finally has a nice scale on it. Look forward to getting that installed. That's brilliant, Luke. Thanks very much. Okay, no idea what that's for. Also there, no idea. Someone's made up a D-bit. Because I gave Luke some M6 left-hand threaded taps, he's now given me a left-hand half-inch Whitworth tap and a matching screw. How useful. Wait a minute. Nope, that's right-hand. Oh, that's a nice little gauge. Nice little mar. Aha. And this was shop-made by Luke. Is the balancing arbor needed to be able to balance these grinding wheels for the Jones & Shipman surface grinder. Luckily Luke's got exactly the same machine as I, and he's also got a cylindrical grinder, so when he made up the arbor for his grinder, he made one for me at the same time. And you can use this tool, of course, to then press the wheel back off the taper if it sticks on too tight. The bluing and the cylindrical grinding just looks fantastic. Not being one to do things by half measures, Luke also designed a matching casing for it, which are 3D printed. Very nice. Oh, and there was one more thing in the packaging, a nice little Mitutoyo dial test indicator. I really appreciate that because I've got a similar size Mitutoyo, but this one's a bit sticky. Doesn't move nice and smoothly. So thanks a lot, Luke. So when it rains, it pours, huh? Up till now, I was doing engraving with this drag engraver, which I made, which is not great for steel because it doesn't really go deep enough. And I had been talking to Luke about high-speed spindles, and he had mentioned that he had an electrical spindle, which he prefers to use, and therefore the pneumatic one was kind of surplus to his requirements. And then after My wife organised that and it was in shipping. Martin sent me the mechanical high-speed spindle. So you'll have to watch this space because I'll definitely do a review comparing drag engraving, super high-speed pneumatic and medium high-speed mechanical for engraving. But for now, a big thank you to my lovely wife for this incredible birthday present. And also to Luke for his fantastic presents. That's just brilliant. Thank you very much. A few more videos coming up there, I'd say. Now this package has just come back from Peter, who's under YouTube as Tala83. Now those of you who know Peter's channel on YouTube, Tala83, know that he's an electromagician. He has the best series of videos on how to set up and how to configure all of the Mesa hardware with Linux CNC. When I blew up my 7i84 I/O card, I bought a replacement for the Maho, and this one's been sitting around waiting for repair. And I need it because I don't have enough outputs on the Shoblin, and I need some more outputs once I get this tool changer going. So I asked Peter if he'd consider having a go at trying to fix this, and I really appreciate that he has been able to. He did a video on that, so I'll leave a link up here. Go and check it out. Give his channel some love. He's doing a fantastic job there. It's a great service. Thanks a lot, Peter. Anyway, what was this week's video about? Oh yeah, dovetail cutters. So I'm going to need my indexer set up on the milling machine. Okay, that's that dialed in square. Next up I need to touch off, so I'll just switch in my Haimer 3D probe, and I've set up my toolpath with the center line of the piece of metal and the very bottom as my origin. Right, next up, let's zero the indexer. Quick 3-line program. So I start by just zeroing it out on its 0 position. And then each time I push ST, the first one jumps to 120 degrees. The second to 240, and the third takes us back to our home position. Now this is the 7-degree D-bit cutter that I've made up to mill these pockets, but unfortunately it's a bit too short because it needs to reach down quite a distance, nearly 30 millimeters, and then I can't grip it very well. So I'll have to make another one from a longer blank. Now I've been working on a D-bit grinding attachment for my Clarkson. At this stage I've just got plastic blocks. This is the first time I use them, so let's see if they're going to work. The Clarkson for tool holding uses a system of extremely close tolerance bushes rather than collets. Bush into bush and then clamp it down. Now first up I need to lock this hole. With that locked, I need to set the cutter so that it's vertical. Need to set the table over 7 degrees. Now for this to work, it needs to be 4 millimeters wide, 4 millimeters up from the bottom. So that's going to be somewhere about there. Still need to take the tip off it, so I can go slightly undersize. Yeah, it's close. I'll just take it down just a little bit more. The next angle I need to put on is the primary relief. I've got a hole here to locate the vertical to split the point, and then I need to turn this way by yeah, I've got this geometry back to front, don't I? If I split the point with the cutter on the other side, I then need to go less than 90 degrees. And what I've got set up for is to go more than 90 degrees. So that's no good. I'm going to have to go to about here and just eyeball it from now. That's good that I made this prototype, because it doesn't work. Right, with that done, the last thing I need to do is just to put a little bit of side relief and clearance on the tip. So that also needs the wheel switched around, which I've done. So now back to this configuration. I can use the 7 degrees that are already set there. I've also got it set 7 degrees nose up. So then it's just a matter of cleaning up that tip. Right, I'll just double check that size. That's set at 4 millimeters. Yep, that looks pretty good. If you're interested, once I get that design finalized, I'll do a video on it. Cuts with quite a burst, I'll just knock that down. Because my D-bit is not ground to an accurate size, I may still need to do a little bit of adjustment here. Yeah, so basically what this means is that my tool's slightly smaller than the code thinks it is. So I'm going to need to just repost the code by reducing the D-bit's diameter a little bit, and that'll cut the pocket a bit deeper. Well, those insets are now sitting really nicely. So the next step is to tap the holes. So to try and get the thread straight, I've got this. It used to be a headstock of an old Emco Unimat lathe mounted onto some aluminium stand from a Black & Decker or something. It's now nearly finished, so I'll take it out and give it a good deburring. I'm really quite happy at how well that D-bit held up. Since this is the tool holder I'm going to mount this in, I'm going to have to just mill some flats on here, just for the clamping screws to hit against. Right, this thing really is a heavy bugger. I really need to make up some sort of a crane system to lift this. Before you bend, extend. Okay, that's all that needed. At this point, with my dovetail cutter finished, it's about time I load up one of my tool holders, and let's take a look at what that dovetail cutter cuts like. Right, well so far this is just the easy job, and that's just cleaning up a dovetail that I was working on when my last cut failed. That has not quite cleaned up yet. When I cut these the first time, I was using my other vise and clamping in this direction. What I'm finding is this dovetail is probably not square. It's probably off at an angle to this vise. So that's why it's cutting here on this side and here on that side. Right, I just tried that on my lathe and that's actually a pretty good fit, so I'll stop there. You can see there's still a little bit of chatter from the old tool, which hasn't cleaned up completely, but I'm just going to leave that because I don't want these dovetails getting too wide. This is now the second nearly finished tool holder that just needs a bit of chatter cleaned up. Okay, this one's still a wee bit tight. So what do these inserts look like after an initial use? Well, that one's still looking good. I'll also give them a quick torque or retighten. Okay, this one needed a bit of a tightening up. That one's also in good condition. Still tight. Oh, this one's starting to chip a little. That's not good. And not loose. With that, I've now finished the two tool holders which were not quite completed before, and I'm pretty happy with the surface finish I'm getting. But the real test of this dovetail cutter is going to be once I hog out a complete dovetail in a new part, but I've run out of time for that today. So for now, we'll leave it at that. I'm hoping the next video I'll be able to finish off some of these tool holders and we'll get to see this dovetail cutter doing a heavier job. Now, if you enjoyed this video, I suggest you set an alarm because Stefan and I are going to be doing a public live stream this evening. Now, I sent this out to my Patreons a few days ago and asked them to please all make sure you show up because we're going to need all of the strength of Team RotarySMP to balance the Team Gotteswinter. Unfortunately, as Kevin pointed out, that the Venn diagram of this meeting is going to look like this. But I hope you'll come and join us. Now, if you missed that first live stream we did a month or two ago, I'll leave a link up here so you can watch that one before you join us for the one later today. Thanks for watching.